Hi, everyone, and welcome to Google Cloud Next on Air. Today, we're going to be talking about some best practices for monitoring user experience and for using custom metric telemetry to do so on Google Cloud using cloud monitoring. My name is Yuri Grinshteyn. I'm a site reliability engineer here at Google Cloud. I'm part of the customer reliability engineering team. I have the good fortune and pleasure of being joined by Mike Debreceni from Niantic. Mike, thank you so much for being here.
Thank you.
And so today we're going to kind of cover three main areas. First, um, I'm really excited to talk to Mike about the experience that he's had actually putting this stuff into real life, putting this stuff into production. So we're going to talk about kind of what they've done to monitor user experience, focus on service health and how they've really implemented some of that stuff. From there, we're going to get into how you might actually start moving on this journey yourself by first creating some basic availability and latency SLOs using Google Cloud Monitoring. And from there, I'm going to dive into some best practices for implementing custom service level indicators using custom metric telemetry. So with that said, let's get into it. First, Mike, thank you so much for being here. Would you mind starting by telling us a little bit about Niantic architecture and scale and your role there?
Absolutely. So I am a site reliability engineer with Niantic. I'm actually the first dedicated SRE and have been with the company for about 3 years. When Pokemon Go launched, I wasn't with Niantic yet, but I was definitely an avid player. I was fascinated by some of the growth and scaling challenges at launch and decided, this is awesome. I want to be part of this. So after I joined Niantic, I helped launch some of the social features, including the friends and trading features for Pokemon, the ability to send gifts, and also the weather features that help with the spawn rates and so on for Pokemon. I'm currently the lead SRE on the Harry Potter Wizards Unite title and support several backend services and monitoring that are used by current and future titles. Our games are enjoyed by millions of players worldwide. I'm going to be a little bit vague about scale, but I will say that we do have a large number of players. We have players that want to play the game 24/7. They want the game to work whenever and wherever they decide to play. We run on the Google Cloud platform and make heavy use of the Kubernetes engine, Spanner, Dataflow, Cloud Load Balancer, and several other GCP services. Our architecture is somewhere between monolithic and a microservice model. We have games that consist of several discrete components, including the front-end server and several back-end services to support the games. So the front-end servers take care of things like keeping track of the game state, player activity, keeping track of game rules. The back-end services take care of things such as supporting our spatial database, player account registry, and then some of the social features. Again, the gifting and friend lists.
All right, thank you. So one of the things you just mentioned were services. So tell me about how do you monitor the health of these services?
When I started, we were using a traditional monitoring approach. So a combination of Prometheus and Google Cloud Monitoring. We actually like the way that the two work together quite nicely. And so we support both. The traditional monitoring approach means that you pick a set of metrics that you think represent how well the system is working. So this will be a mix of system metrics like memory and CPU use, and then game level metrics that might be things like how many Pokemon are being captured, how many spells are being cast, how many players are logged in. You then set thresholds for normal and then watch for things that indicate something unusual is going on. So maybe we see that the number of players has dropped off or the number of successful Pokemon copters has suddenly dropped off. And this works fairly well. There are some limitations to this approach. So number one, it tells you how the servers are doing, but it doesn't necessarily tell you how the players are doing. There's some guesswork involved in picking the correct metrics and figuring out which metrics matter. Also picking appropriate thresholds so that you end up with alerts that are sensitive, but not so sensitive that they're to the point of being noisy. It's very, very easy to focus on wrong metrics, and it's very easy to miss problems that may involve a combination of metrics that combine in ways you never anticipated. One of the things that we've learned is that distributed systems tend to fail in very complex ways. With Wizards Unite, we piloted a SLO monitoring approach with the help of our partners at Google to complement our traditional monitoring. So the approach here is to look at the game from the point of view of players rather than the servers. So We measure things like request latency, the success rate for requests from players, both overall and then or a more detailed level, such as the individual actions that they may perform in the game. We then set performance targets for these metrics and end up with service level objectives, or SLOs. We can then also track error budgets based on how well we stick with these SLOs and how well we comply over the long term. We then alert based on SLO violations or if we start burning error budget excessively.
Okay, makes sense. So it sounds like some of the primary reasons you adopted SLOs were to really focus on user experience and kind of how the users are perceiving the game. Um, was that the primary motivation? And then what other benefits did you see from making this change?
So there are a couple of benefits. So yeah, as we realize, players are not really interested with the details of our server. They do care if the game is working, though. So we should measure that. So what we found is that by implementing a couple of very simple SLOs based off of the metrics from our load balancer, latency and success rate, we were able to tell a lot about the player experience. They also keep us very honest because we're not depending on the servers to report their own metrics. One of the things, obviously, is that if the server crashes, it's not going to report anything that says it's in trouble. Something else has to do that. So the effect of this is that problems have nowhere to hide. If there's something going on, whether it's something internal within the server or something with our network infrastructure, we're going to see it as an SLO violation if it affects the players. And then we'll receive an alert. So some of the benefits, we tend to see better quality alerts. We have much less alert noise with our SLO violation alerts. We do know that when we get an alert, we know that there's something going on that we need to address. The alert doesn't necessarily tell us what the problem is, but it does let us know that we need to start our troubleshooting process. And this is where we may look at some of our existing traditional monitoring. It's also actually taught us a couple of things about our deployments that we've done and some of the regressions that may come up afterwards. So we found that by watching outside of the servers, we can now see the effect of doing even things like a deployment or planned maintenance. This means that we've actually changed the way that we do some of our deployments based on some of the observed disruption that we were causing. The other thing that we've noticed is that we can watch for what's called a slow burn alert, where we're very slowly consuming error budget, but faster than we should be. This would be something like a slow leak in a car tire, where you may not notice that there's a problem from day to day, but you will definitely notice when you have a flat tire. So what this is, it's watching the cumulative effect of small SLO violations that may start after we've made some change. This would be lost in the noise of a traditional monitoring approach. But with our SLO monitoring and our error budget tracking, they're now very visible. And now we know again that we need to start looking for a regression.
So this sounds great. Now you have a better sense of user experience. Your alerts are of higher quality. When you get an alert, you actually know that there's a problem. You can also catch problems like the slow burn situation that you described. So this all sounds great. What's been the hardest part about making this transition and making this change?
I think selling the idea internally was actually one of the harder things. A lot of people understand what traditional monitoring is, but they don't understand necessarily why we also want to do SLO monitoring. Why isn't traditional monitoring good enough? So I had to explain that this is a complement to traditional monitoring. We're not replacing our existing monitoring. We're just adding to it. We're doing something that means that we're looking at the same metric data, but in a different way and interpreting it differently. One of the benefits that we realized is, again, detecting problems that we didn't even see coming. The other obstacle that I ran into is the conception that SLOs are just for SREs and nobody else needs to pay any attention. And actually, this is not the case. We definitely need and want input from product and the rest of the business. As SREs, we're very good at measuring things. Product is very good at knowing what we need to be measuring and what we need to be looking for. Unfortunately, the product team is also very busy, and unless they understand their role in coming up with good SLOs, it's hard to get their time. So the approach we took was to make this as easy as possible by focusing on one or two starter SLOs where we had a pretty good idea and just needed confirmation from product. Once we had that and could demonstrate some value, we were then able to bring in product and work on some more advanced SLOs.
Yeah. So selling this internally is a challenge. Getting product to buy into is a challenge. That certainly makes a lot of sense. I totally get that. Looking back on your journey, would you have done anything differently, or what would you do differently?
So one of the things that I would have done is to start simple, demonstrate value quickly, and focus on the quick wins before taking on some of the more advanced use cases. So as an example, one of the things we tried to do was set up SLOs based off of the custom metrics in Prometheus. This involves setting up a sidecar which ingests metrics into Stackdriver. We had some concerns about the cardinality of that metric, or the metrics that we were using, and wanted to pre-summarize the data before sending it in to the cloud monitoring service. We found that that was actually, at the time, fairly difficult because the sidecar was in a fairly early development state compared to where it is now. So we ended up working with the development team behind the sidecar and were eventually able to add the feature that supports aggregated metrics coming in. This was a huge help for us. It let us do what we want, and the sidecar is now in a much better state. However, it did take a long time to get something. Looking back, I would have just started with the load balancer metrics. They actually gave us something useful very quickly in about an afternoon's work, and that gave us about 90% of what we were looking for. They were also much, much simpler to set up.
Yeah, I can understand that. Just using the out-of-the-box load balancer metrics rather than kind of building your own with Prometheus, and then also maintaining that additional sidecar infrastructure, would certainly make things a lot easier. So that's an excellent lesson to pass on to folks that are looking to start their journey down this path as well. Um, other than that, what else would you advise someone who's looking to kind of follow your footsteps and reproduce this?
So I would say don't be afraid. This is actually not that hard to set up. It's it like I said, with the load balancer metrics, we had something in an afternoon. It was very straightforward. The other thing I would say is that if you can measure it, you can turn it into an SLO. So think about the existing metrics that you already have and see if there are ways that you can turn them into an SLO that describes user experience. Obviously, there are some that will work very well. In our case, the load balancer metrics were very helpful. They were free, they were available out of the box. Don't forget also to start simple and go with a quick and easy win before taking on the more advanced challenges that may need some buy-in from others. Finally, pick the right tools. Pick a tool that's flexible and that works well with your existing environment. In our case, we chose the Cloud Monitoring SLO API from Google. This supports creating many types of SLOs, works on all cloud platforms, and supports containerized and virtual machine environments. We're very happy with how it's worked out for us.
All right, thank you very much. I appreciate that. And again, thanks for being here. I think this is, some super useful lessons that I think you have learned that I'm very happy that you're able to, pass on to others. So thank you very much again. From here, what I'd love to do is to walk through some practical examples of how folks that are watching this session can take some of the lessons that Mike has learned and apply them to your own environment. First, I want to show you how to, do exactly what Mike is saying, is how do you create some of those basic availability and latency SLOs using some of the out-of-the-box features in Google Cloud Monitoring. They're there for you to use without really the need to do any additional application instrumentation. The way that this works is that you essentially have to start by kind of defining your service, right? The basic premise here is that you have a service, and you can be measuring service health using service level objectives for that service. There are two primary ways by which you can define the service using the UI, right? If your service is running on Google Kubernetes engine or GKE, the UI will actually let you pick one of the GKE primitives to essentially create this logical construct that you can use as a service. So you can use things like GKE services, GKE deployments, even something like a GKE namespace, and tie your service definition to that. If your GKE cluster has Istio installed on it, which is an open source service mesh that allows you to do things like traffic routing, security, encryption, and telemetry or observability, then services running within the Istio service mesh will also be exposed for you here, and you can simply pick one of those. So that's the first step, right? Is either select the service that's already been defined or define it yourself. If you're not running on GK, if you actually want to define just a custom service, there's an API available that you can use to do that as well. So that's the first step, is select the service or define the service. The next step would be to pick the SLI. SLI stands for Service Level Indicator, and this is the metric that you're actually going to use to essentially determine, at any given point, is your service healthy or not, right? This is a thing that you're measuring that you can be using as a proxy for user happiness, right? Are my users happy or are they not? So specifically for Istio services, the SLO monitoring screen will actually allow you to pick availability or latency right there, because it's aware that of what an Istio service is. It knows the Istio metrics that are used to expose things like availability and latency, and you just pick the kind that you want to use. If this is not an Istio service, you can actually select Other and essentially pick any metric within Google Cloud Monitoring to be used as the SLI or service level indicator for that particular service. And then the last step is to actually define the service level objective, right? So you may recall that the service level indicator is the metric that we're going to use to measure service health. The service level objective is the target that we're going to put that will actually tell us, whether our service is healthy enough, right? So that's the last step of the process. Is you set your SLO. You determine, what is the level of reliability that this particular service needs to deliver. You specify the time window over which you're going to measure it. You have the option of using a calendar window or a rolling window and the length of that window. So then I'm going to show you what is your SLO compliance looking like right now based on the metric that you've chosen, your window and your threshold. You figure out if that's what you need, if that's the right target for you. And then you just save the service and you're good to go. So defining an SLO for a service that you either create or define yourself, for metrics that are already there for you out of the box, is fairly straightforward. In this last part of the presentation, I want to talk about, what do you do when the metrics that you want isn't there? How can you go about adding custom metrics to Google Cloud Monitoring in order to use them as service level indicators? I'm going to discuss, 4 major options, right? So again, these are metrics that aren't there for you out of the box. So using load balancer metrics that Mike had already talked about would be a great place to start if that's an option for you. I'm going to talk about specifically cases where the metrics just don't exist. What can you do? So I'm going to discuss 4 options. Log-based metrics, using the monitoring API directly, using a custom instrumentation library like OpenCensus or OpenTelemetry, or using Prometheus, which is a well-known open source time series monitoring toolkit. And as I go down this list, I'm going to talk about kind of the basics of each one, how you might go about implementing it, and then talk about some pros and cons of each so you can kind of understand what are the trade-offs of all these different approaches. So let's start by talking about log-based metrics. Right. Fundamentally, log-based metrics are the idea that you can take numerical values in your logs payloads and convert them into metrics. Out of the box, we ship metrics that are called system logging metrics, right? So these are things that measure, for example, log volume ingestions and other things that you can understand, how much logging is happening within your project, and really how much that's going to cost you. You can then define 2 different metric types based on your application or system logs. Counter metrics would be just things that kind of tell you how many times do you see entries that match the particular filter. Right? Distribution metrics are primarily what you would use for SLIs because you can actually use them to extract, using a regular expression, numerical values from the logs payload. Right? So this would be useful for tracking things like latency. So if you want to have a latency SLI and maybe that latency is being written in the log somewhere, you can use a distribution metric to do that. Whereas if you want to do an availability SLI where you're just counting, how many errors, for example, take place versus number of total requests, then you can use a counter metric. Obviously the big trade-off of using log-based metrics is that this data has to exist in logs, right? So you have to have logs, and you're going to be paying for those as well. And this, if you already have this information in your logs, this could be a great place to start, right? You should know that if you're excluding logs, right, to save on cost or save on storage, you can't configure log-based metrics on logs that are being excluded. Right? One other thing you should know is if you want to use SLO specifically for alerting, because there can be a delay between when logs arrive in the system and when those values are essentially aggregated for the purposes of log-based metrics, if you want to have very precise alerting, this option may not actually be, the data latency may not be sufficiently low for that purpose, right? So when thinking about log-based metrics, right, the big kind of advantage of this approach is that it really doesn't require you to do any additional instrumentation. If the logs are already there, you can just use the data. The big trade-off is going to be things like data latency, but also you need to have the logs there, and this could result in additional charges for you. Your second option for custom metric telemetry instrumentation may be actually using the monitoring API to create the metrics directly within the monitoring backend. So the way that you would do that, and I'm going to walk you through some kind of a basic example of how you would do that specifically using a Node.js. So first, you set up the configuration, right? This is where you kind of set up, what is the metric that you want to write, its type, its how you would actually retrieve it, and things like that. Right. The next step is you create what's called the metric descriptor. So this is just kind of it tells it provides the API a way to determine whether the values are going to be written. Then you create a data point object. Right. Your data point is going to have an interval that describes when this information is being written, and then it's going to have the value of like what's the number, what's the time series value you're actually writing. From there, you use the metric descriptor to create a time series. So remember, in Google Cloud Monitor, you can have multiple time series against a specific metric descriptor. So this is where you create the particular time series, and finally, you actually make a call to write your data point value against that particular time series. So as you just saw, there's a lot of steps involved if you want to use the API directly, right? The big advantage of using the monitoring API directly is because you're interacting at the lowest possible layer here. You have all the control you need. So you have full control over exactly how the metric descriptor gets created, how the time series get created, how the data points are written. Right. So if you need that level of granular control, using the monitoring API is a great way to accomplish that. As you saw, the big trade-off here is complexity, right? You have to manage all of these different things. So there's probably a better way to do that, right? And what we recommend if you actually want to do this kind of instrumentation is to use these custom instrumentation libraries. So you should be aware that in the past we've recommended OpenCensus, which is this open source metric and trace instrumentation library that actually came out of the Census library here at Google. Recently, there's been an announcement that OpenCensus is actually merging with the OpenTracing project in a new project called OpenTelemetry. So I'm going to show you examples of how to do custom metric instrumentation both in OpenCensus, which is a project that's been around for a little bit longer, and also OpenTelemetry, which is a newer project. So let's take a look at a code example of how to use the OpenCensus metric instrumentation library in Node.js to define a custom metric, right? There are basically a couple of steps that you have to do. First, you define a measure, and then you define a view, right? If you think about kind of back to going to the monitoring API, right, the view is going to create the metric descriptor, the measure is going to create the specific time series, and then you're going to actually write values against those. One thing that you should notice is here at the bottom, when I'm creating a latency metric, because I want to have a latency SLI, I actually have to explicitly specify the buckets of my histogram, right? OpenCensus does not allow me to do that automatically. It's very explicit about the fact that this is something that I'm required to do as I write my instrumentation. So you should be very cautious when you're going to be tracking latency within your application using OpenCensus, and you want to use this kind of histogram approach. When you define the buckets, you need to define the buckets in a way that will actually allow you to create meaningful SLOs, right? Your buckets have to be precise enough to capture the values that are basically within SLO versus those values that are outside of your SLO. As the next step, once I've got the metric, I can then go and create my service level objective, right? So this is an example of an API call that I would use to specify the service level objective. You can see that I'm using a request-based SLO, and I'm basically saying I want to count the requests within a specific time interval whose response time threshold is lower than my value, or across total requests. And then I just put a goal on that SLO, which is what percentage of requests have to fall within that particular time value, right? When I look in cloud monitoring, right, there's my metric, and then I can create SLO with that, right? So kind of summarizing OpenCensus, right? You have to basically create two different primitives. You have to create a measure to define the type of the metric, and you have to create a view to define how that metric is going to be aggregated. And then specifically for latency SLIs, you need to be careful about how you define your histogram bucket to make sure that they're precise enough to capture the thresholds that you're then going to be defining in your SLIs. Let's now take a look at an example of how you do this with OpenTelemetry, which is the new project, right? If we take a look at the code, we'll see that defining the metric is quite a bit simpler, right? I don't have to go through the process of creating a view and a measure. I just simply create the metric, and there I am, right? And all I have to do is then essentially issue a call to write the values. So defining my metrics using OpenTelemetry is quite a bit easier, which is obviously great. The big trade-off, kind of the thing that's actually lacking in OpenTelemetry today, is this idea of an exporter. So in OpenCensus, there's essentially a native exporter that essentially allows me to write metrics directly to the cloud monitoring backend. OpenTelemetry does not yet have an exporter for cloud monitoring for metrics. And so I have to essentially use an intermediary to get my metrics from my application into the cloud monitoring backend. And in this example, I'm actually using the Prometheus exporter, which also will then require me to set up the Prometheus integration with cloud monitoring. But once I've done that, I can then go ahead and define my SLO in the same way that I did when I used OpenCensus. And you can see the metric here actually has the external.googleapis.com/Prometheus prefix, right? Because I'm using the Prometheus exporter, the metrics actually make it into the back end as as Prometheus metrics, right? So looking at the differences between OpenCensus and OpenTelemetry, OpenTelemetry does make it easier to declare the metrics. So the application side instrumentation is, I think, quite a bit easier to use. The trade-off there is the ingestion instrumentation is a little bit more complex because you actually need to have an additional layer of infrastructure to do the ingestion, and you have to use Prometheus as that intermediary, whereas OpenCensus allowed you to just write those metrics directly. So looking at the combination of OpenCensus and OpenTelemetry, right, your big advantage here is that you write the metrics directly, and also if you want to get started with distributed tracing, you can actually use the same library to do both tracing and metrics, both in the case of OpenCensus and OpenTelemetry. The trade-offs are going to be, right, what language is your application written in? Does it have support for, does OpenTelemetry or OpenCensus support your application language? And specifically in the case of OpenTelemetry, how are you going to get the metrics into the backend, right? Are you going to be willing to manage the Prometheus infrastructure to get that ingestion to happen? Which obviously brings us to our last option, which is, well, we can not use application level instrumentation libraries, we can just use Prometheus directly, right? So Prometheus is kind of the de facto standard for monitoring in the open source ecosystem. It's certainly been something that folks have been using on Kubernetes for quite a while. There's lots of integrations that are available. The big trade-off with Prometheus is there's essentially two additional pieces of infrastructure that you actually have to maintain in order for this to happen. One is you need the Prometheus server itself. So in the case of applications running in GKE, you need to have the Prometheus server deployed in the same cluster where your application is. And then the second thing you need to do is you need to actually patch that server with what's called the Prometheus cloud monitoring sidecar. The sidecar is what's going to take the metrics from Prometheus and import them into cloud monitoring. So for kind of a specific example of how this would actually work, right, let's take a look at the code first. You can see that declaring metrics in Prometheus is just essentially just as easy as it was in OpenTelemetry, right? This is a very mature library. It's been around for a long time. There's lots of examples of how to do this. In my example, specifically for latency SLI, I again have to manually or explicitly manage my histogram buckets. And again, I just have to make sure that I'm setting them up in a sufficiently precise way such that I can then define SLOs using those metrics, right? And here's an example of how I would write an SLO using Prometheus metrics, right? So kind of summarizing that, right? You can use request-based SLIs using Prometheus metrics, pretty straightforward. The big trade-off there is this need to maintain additional infrastructure and a sidecar. And specifically to measure latency using Prometheus, you do need to be very precise about how you define the buckets to make sure that your buckets are essentially precise enough to capture those requests that are within SLO and those requests that are out of SLO at a bare minimum. So those are all the options that we've kind of gone through as to how you might go about instrumenting your own applications running in Google Cloud to expose additional metrics that you can use for service level indicators and then for service level objectives. To summarize everything we've talked about today, right? Just like Mike said at the beginning, there's a lot of value that you can get just by starting with the out-of-the-box metrics, like load balancer metrics and things like that to define SLIs. If you need to create your own, evaluate your options, right? There's going to be trade-offs with each one, so kind of figure out what makes sense for you. But ultimately, it's really important that you focus on user happiness in your monitoring, that you really understand, who are our users, how do they use our services, how do our services enable them to meet their goals, so that you can really measure and manage reliability by focusing on the end user, right? Here's what you get when you do this. You get SLO dashboards and cloud monitoring that looks like this, right? You get all the SLOs in a single place. You get any alerts that are associated with them. And as we've covered over the last few minutes, the SLOs can be created on metrics that are ingested automatically or all the custom metrics that we've just talked about. You also get this in-context information about things like metrics and logs and underlying infrastructure. So lots of value that you get by using this approach to monitoring rather than just relying on infrastructure metrics. So thank you so much for watching. If this is a topic that you have additional interest in, here are some other sessions in this track that you may want to tune in. We really appreciate it. Thank you again for watching. Mike, thank you so much. Really appreciate you being here. And take care. Be safe. Thank you.